everyone, welcome to Learning at 11th Hour. In this video, we're going to see how we can replace a linear passive network which is reciprocal with its pi equivalent. Now, when I say pi, this is the shape that comes to our mind. So, we are going to replace the two-port linear passive network with circuit elements which is going to appear in this particular configuration. So let me first begin by writing out the equations for the two-port network in terms of the y parameters. So to begin with, we'll have the currents on the left hand side. I1 is equal to y11 V1 plus y12 V2, and I2 is y21 V1 plus y22 V2. We can now draw the port based representation with the help of these equations. So on port 1, we are going to have current 1 which is entering. There's going to be this admittance Y11 which is connected across the positive and the negative terminal, where the voltage is going to be V1. That is going to be connected to a voltage controlled current source given by Y12 V2. And on the port 2 side, we are going to have another current controlled voltage source given by Y21V1, and we are going to have Y22 in parallel with it. I2 is going to enter this port, V2 is going to be the voltage across this, and these two ports are connected in this manner. So this is the port based representation in terms of the Y parameter. Now we are supposed to replace this network with another configuration that assumes the shape of a pi, the symbol pi. So it's supposed to look like this. So here we'll have, say, YA. Here we'll have YC. And here we are going to have YB, where this is going to be port 1, this is going to be port 2. So this is V2, this is V1. The current entering here is I1 and entering here is I2. So how am I going to write the terms YA, YB and YC in terms of Y11, Y12 and Y21 and Y22? So we're going to see that, right? So in my previous video where I would have discussed about Y parameters, I would have taken up this example where I would have shown you that we can obtain the expression for Y11 as YA plus YC. Y22 was obtained as YB plus YC. Y12 is going to be equal to Y21, which is the condition for reciprocity. This is a main parameter that has to be satisfied. The circuit has to be reciprocal. Only then we can obtain the pi equivalent for it. So obviously Y12 should be equal to Y21, which is the condition for reciprocity, and here it is going to be equal to minus YC. So this can be obtained, of course, from these equations where we can short the second port, find out the parameters, and then again short the first port and find out the different parameters. So that would have been discussed in the previous video. Now we need to find out the expression for YA, YB and YC in terms of Y11, Y12 and Y21 and Y22, which can be done very simply in the sense that Y11 is YA plus YC. So if I want to find the expression for YA, I can subtract yc on both sides. So now what I have is the yc and yc will go. What will remain is ya. And we know that y12 is minus yc. So I can just replace the minus yc with y12 and keep the rest of the term intact. So what I get here is ya is equal to y11 plus y12. So ya is y11 plus y12. On a similar note, I can find out the expression for yb. So we see that y22 is equal to yb plus yc. Again, if I subtract yc from both the sides, what I will get finally is yb will remain on the right hand side. On the left hand side, I'll have y22 plus y21 because y21 is minus yc. And yc here is nothing but minus of y21. So that's the third parameter. Yc is minus of y21. So now we have obtained the pi equivalent of our reciprocal two-port network, and it appears in this manner. So this is going to be the pi configuration. So this will be V1, this is going to be V2. This was YA, YB, and YC, which we have obtained as Y11 plus Y12, Y22 plus Y21, and minus Y12 or minus Y21. So effectively, this is going to be the pi equivalent of my two-port network. Let's look at a simple example problem uh, to get a clearer picture of this concept. So say this is how the question goes. We've been given the equations for the two-port network. Looking at these equations, since the left-hand side is currents, so these values are going to be y parameters, right? So from the equations, we can see that y11 is 0.5, y12 is minus 0.2, all of these are more, y21 is minus 0.2 more, and y22 is 1. So we've been asked to obtain the pi equivalent for this network. So this means we have to compute the values of ya, yb, and yc. So this is yb, this is going to be yc, I1, I2, this is V1, and this is V2. Now, the first and foremost step that we need to perform is to find out whether the circuit is reciprocal or not. So, looking at Y12 and Y21, we see that Y12 is the same as Y21, which is minus 0.2. Therefore, we can say that this network is a reciprocal network. So only when the reciprocity is satisfied, we can actually compute the pi equivalent for that network. So now we can say that YA is going to be equal to Y11 plus Y12, YB is going to be Y22 plus Y21, and YC is going to be minus Y12, which is minus Y21. So in those terms, we can say that YA is equal to 0.5 plus minus 0.2. YB is 1 plus minus 0.2. And YC is 0.2 because it's minus of minus 0.2. So that's plus 0.2. So we can obtain YA as 0.3, YB is 0.8, and YC is 0.2. So now we can replace these values here. This is 0.3, this is 0.2, and this one is 0.8. So this is how we can obtain the pi equivalent of any two-port network that has been represented using the y parameters. So if we know the z parameters, even then we can find the pi equivalent of it, provided the circuit is reciprocal, and from the z parameters we are able to obtain the y parameters, and from that we are able to obtain the parameters of the pi configuration. So that's all with today's video. I hope the concept of obtaining the pi equivalent for a two-port reciprocal network is clear to you all. Thanks for watching.